This is the area we're trying to find the centroid for, right? So the problem statement could be very simple as locate the centroid of the plane. Right? It's a plane in XY plane. You see where the coordinate system is. Those two axes, X and Y. We want to find out where the centroid is. Now, one way to do it is, which is a good practice, it would be to break it into simple shapes. Now, you might come out and say, I'm going to break it into this triangle here. Let's say I'm going to break it to this segment, and this segment. And for each, if you go back to the table, well, for the triangle, the reason for the rectangle, the reason you don't see it in a table, because for a simple rectangle, the centroid is very straightforward, right? It's, let me add it here. That's why it's not brought here. If your, let's say, coordinate is here, your X bar would be, this is your center, your X bar from here to here. And this is going to be your Y bar. So this, I can use a ruler to make it more straight. This is Y bar. So if the width of your rectangle is, let's say, A and the height is B, then your X bar is basically A over 2, and your Y bar is basically also B over 2. Right? It's a simple case, and that's why we don't see it explicitly here. All right, that we can add it to the table you have. X. Oh, don't use X and Y. Just go with the distance, because then it gets confusing. Right? That's for a triangle, rectangle. This being the center of the centroid. So this is the most simple shape possible. So that's why it's not really provided there. I guess it's like pretty much following the logic. Now, looking at this, if you break it into these three shapes, shape one is a triangle. Well, you know how to find the centroid of a triangle. We'll get into that. Segment 2 and segment 3 both are rectangles. Right? So we can divide each side and then find where the centroid is, right? For centroid for this one is going to be here, centroid for this one somewhere here, and centroid for this one is here. Then we just have to find the coordinate of the centroid for each and then form that table. However, I want to do it in a different way. So you can see we can also subtract areas. Right? This is one approach. There's three segments, find the centroid and then form the table and find the general centroid for the composite area. Now, what I want to do is that I want to say this shape I have, right, can be a combination of this shape plus this shape. Minus, sorry, not plus, minus this shape. Right? If you do that, you're going to end up getting, let's put it this way, this. End up getting this. Right? If I divide this, basically what I'm trying to say, this is segment 1, this is segment 2. So you add these two segments together, and then you have segment 3 minus segment 3, you'll get the shape here. So you can do subtraction. It doesn't have to be addition all the time. That's why I wanted to do this approach. Previous approach I mentioned, we can do that, and you will figure it out. Right? You should get the same same result as what we are going to get with this, right? Because centroid is in the same place, it doesn't change. So here's what I write. I say break it into 3 segments, right? Let me draw that table. The same table we use for wire. Now we're gonna similar table. We're gonna use. Let me give myself more room. So this is frame number I, right? Well, don't put frame, segment. So segment 1, segment 2, segment 3. I have 3 segments. For each segment, remember, these are the equations I'm trying to find. This is in 2-dimensional area, so I'm trying to calculate XC, which is basically, I'll write it here. I'm trying to calculate XC, which is basically sum of X by R's AI over sum of AI's. So it's X1 A1 plus X2 A2 plus X3 A3 divided by A1 plus A2 plus A3. Right? In this case, I'm not going to write it this way because it has to be negative, minus. Just let me write the general form. And then YC, you will get summation of Y bars AI over sum of AI's. Right? That's what we're trying to, these two are what we're trying to calculate. This table is going to help us to find the numerator and denominator for these equations, for these fractions. So same procedure that we did for a line. I'm going to start with area AI. We'll just put A. Next we'll have, let's say, X bar. We have Y bar. Let me see if I give some room here. X bar, Y bar. Then we'll have X bar A. You have Y bar A. Right. And we have to find these for each segment. Right. So area for segment 1. Segment 1 is this triangle. Right? What is the area? Is base times height divided by 2. Right? It's basically just a simple triangle. This is the area of segment 1. So that would be 3 times 3 divided by 2, 4.5. The unit for these are also is foot, so square foot. Right. Let's do all the areas. Let's just do column by column. Maybe that's easier. So segment 2 is this one. Here is the segment 2. What is the area for segment 2? Area for segment 2.
Can't you just do 2 times 3?
Yeah, pretty much. 2 times 3, exactly. So it would be 2. Well, not 2 times 3, 3 times 3, right? This is 3 here, and this is 3 here. Now we're looking for the area for the whole section. So 1 foot plus 2 feet, then another 2 plus 1, so it becomes 3 by 3.
I was wouldn't it because there's three segments and the third segment separate. So wouldn't you just
Well,
call a rectangle all by itself? So it's a two by three.
so we get the rectangle as segment two. So what we're doing is that we're saying this is segment one and two, right, which covers this whole area. Let me just draw it here. This is segment one and two. Now we're going to say, well, segment three would be a cutout. This area. This would be segment three. So we find segment one properties, segment two properties, segment three properties, but we make sure that we subtract segment three from segment one and two. So in that sense, segment two is the whole um, area there. This is segment two.
Oh, I see. I thought we were adding segment three, not subtracting segment three.
Yeah, we are subtracting it, right? Taking segment two as the whole and segment three subtracting from that point. So that makes the area for segment two 9 square foot. Right? For segment three, well, maybe so crowded here. Segment three, the area would be 1 by 2. Right? But we have to remember that that's negative because it's a cutout. Right? So it becomes minus 1 times 2, becomes a minus 3. Oh, wait, I put minus 3, minus 2, minus 2, right? That's for area. Let's look at X bars for each segment. Starting with triangle. So this is the part that I want you to pay attention. This is X, right? This is X axis. So I have to find out wherever this centroid is, I have to find out this is the origin. I have to find out what is its coordinate. Where is it, X bar? In this coordinate frame. Let's go back to the table we have. Right? This is all we have for the triangle. This is all we have for the triangle. What does this tell me? It tells me that centroid is located at 1/3 of height from the base. Now, in this case, we have a pretty neat triangle that is like this. So centroid is located at 1/3 in this direction. If I call this A, I call this B. 1/3 in this direction and 1/3 in this direction. 1/3 of the distance from the base. Now, where is the base? Well, it depends on how you look at it. Right? In this case, this is your base, and your centroid is located at this distance, which is the 1/3 of this height. This is 3 feet. So this is 3/3, which is 1. Again, you have your triangle here. Let me clean things up. Now we're trying to find its centroid. I want to make sure you understand how you use the table. This is the triangle we're looking at. We want to find out where the centroid is. Let's say here. This centroid is located at this distance from one side and this distance from this side. From this side, whatever is the height divided by 3. From this side, whatever is height divided by 3. So if you divide this, 2 plus 1 is 3, divided by 3 is 1. Right? And we got it from our table. From our table, knowing this about the triangle. We know that the centroid is located as 1/3 from one side. All right. So knowing that X bar becomes well, we're looking at where this centroid is in the global coordinate frame, right? So 3 divided by 3 is 1. Right? This is 1. Let's look at the X bar for segment 2. Where is X bar for segment 2? This is our segment 2. Right? This is the triangle. Segment 2 is this area. And this is our segment 2. All right. So where is the centroid? The centroid is somewhere here. Like this is a typical, I would say, rectangular form. So what is the X bar for this? What should I put here? Segment 2 is that 3 by 3 area, right? What is the coordinate of the centroid for this area in this coordinate frame, XY coordinate frame?
Would it be 1.5?
1.5, right? But negative, right? Don't forget that. It's on this side. So negative 1.5. It's in this coordinate system. So this becomes minus 1.5. The unit for this is foot. This is foot. This is foot cubed. Foot cubed. All right. All right. Section 3. Now here is a tricky one. What is the coordinate of centroid for section 3? Remember, this is the coordinate system we have. X, Y, X, Y. Right? This is X. This is Y. What is the coordinate of X bar, or the X coordinate for the centroid of this triangle, which is a 1 by 2 triangle?
Would it be negative 1/2?
Negative 1/2. So this is half, right? I agree with you on that. This is half. But knowing that it's half, what would be the X coordinate in this coordinate frame? Remember, this is where the triangle starts, right? This is where the triangle is. So here is the center. Let me clean the other one. Put it into this form here, right? We have this. This is the center. See. So where is this? What is X bar?
Is it negative 2.5?
Negative 2.5, exactly. Right. Looking at Y bars, for 1, right, area of segment 1, again here, we go back to that segment. Right, in this segment, wherever the centroid is, we said this is where the centroid is located. So this height from the base. Well, this is 1/3 from the table. We know it's 1/3 from that side of the triangle. So 1/3 from this. The whole thing is 3. Let me put it a little higher. So the whole thing is 3 here. 1/3 is 1. So it's 1. And it's the opposite side of Y. Segment 2, again, this triangle here, this area. What would be the y for this? I'm trying to fill this cell. What should I put there?
Positive 1.5.
Positive 1.5, exactly. So that would be, let me erase that. 1.5, right? And the third one would be section 3. This segment 3, this is the segment. This is the centroid in the middle. What is the y coordinate for this?
Two.
It's 2, right? So 1 plus half of that, which is 1, makes it 2. Now the rest, 2 other columns are just calculations. Right? You just say, well, x bar 1 multiplied by area is just 4.5. Y bar multiplied by area, again 4.5. X bar multiplied by area for segment 2 minus 1.5 multiplied by 9. I don't know that. You'll get minus 13.5. Y bar multiplied by area 1.5 times 9, well, it becomes 13.5, but this time positive. Right? For segment 3, you'll get minus 2.5 times minus 2 becomes 5, positive. And then 2 times minus 2, minus 4. Right, so this becomes right there. Now, what am I looking for? I'm looking to form this. Right, xi bar ai over summation of ai. Now xi bar ai, sum of all of them is basically the summation of this column for this column. 4.5 plus 5 minus 13.5. That gives you minus 4, right? Minus 4 here. This is, let me write it this way. X bar A minus 4. So you get the numerator as minus 4 divided by sum of the areas. Sum of the areas is a summation of all the elements in this column. 4.5 plus 9 minus 2. Right? It gives you 11.5. Right? So you put 11.5 here. Make that, do the math, you'll get minus 0.348 foot. YC, you'll get summation of yi ai divided up by ai, right? If you sum these up, well, the summation of the numerator is basically the sum of the elements in this column. Minus 4 plus 4.5 is half, 13.5, this becomes 14, right? Y bar A is equal to 14. So that's the numerator. Denominator is sum of the areas, which is column 1, 11.5. Well, that'll give you 1.22. So this tells me that the centroid for this composite area is located at minus 0.348. This is here, somewhere here. Let's see if it's 1 half is somewhere along this line. And then y of 1.22. So centroid is somewhere here for this composite area. Right? So knowing the area properties, in this case, because we're dealing with areas, centroids and areas for each component or segment we can find the centroid for the whole composite area.